Okay, in this video we're going to talk about our trigonometric derivatives and then how those combine with other derivative rules. So first we need to look at what are the rules of our derivatives for trig. So the derivative of sine is cosine, the derivative of tangent is secant squared, and the derivative of secant is secant tangent. And then you have the other three over here. So the derivative of cosine is negative sine. Derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant cotangent. So if you remember this side, you pretty much know this side. Notice that any derivative I take of a function that starts with a c is going to be negative. It's going to have a negative value. Okay, but if I know the derivative of sine is cosine, then the derivative of cosine is negative sine because it had a c. Cosine is a c. I take a derivative of trig that starts with a c, and I'm going to have a negative answer. Okay? All right, so these are for very basic functions when all I have in here is x. These are the rules that you have to know when there's an x in here. But how do we use these if there's more than just an x? So here's an example. The derivative of sine with something inside more than just x. Okay, what I'm going to do is I'm going to be taking the derivative of the outside function, so the derivative of sine is cosine, and everything inside is going to stay the same. Notice how the f of x matches. But then I'm going to multiply by the derivative of the inside. So I am taking the derivative, this might help you to write this down, the derivative of the outside, okay, where the inside stays the same. So whatever is inside your trig will stay the same. Always. Okay? Derivative of outside, inside stays the same, times the derivative of the inside. So times the derivative of the inside. So this is very similar to chain rule. This is our chain rule version for trig. Okay, so let's look at an example now. This is sine of 4x, so we could put parentheses if we want to, and so this is my inside. So when I take the derivative of this, I'm going to take the derivative of the outside, so the derivative of sine is cosine, and those are just rules you have to get familiar with. The inside stays the same, times the derivative of the inside, and the derivative of 4x is 4. And then personally, when I write this, I'm going to write that 4 in front. So I'm going to write 4 cosine of 4x. And you can either put the 4x in parentheses or not. Okay, so you have to just get familiar with the rules, and you have to be very careful not to miss things like this multiplying by 4. So let's look at this one. This part is my outside function. This is really 2 times cosine. And then this is the inside. So I'm going to have the derivative is going to be 2 times the derivative of the outside. So we're taking the derivative of cosine, which is negative sine. Inside stays the same. Times the derivative of my inside, which is going to be 3. Okay? Notice that whatever's in your trig function here will be in your trig function here. That's not going to change. And then here I have 2 times 3, and I also have this negative, which is like having a negative 1. So I'm going to multiply those. I'm going to get negative 6 sine of 3x minus 1. And that's your derivative. Okay, I want you to take a minute and try this one. Pause the video and then check it with me. Okay, so here we're taking the derivative, and we're going to have the derivative of sine is cosine. Inside stays the same, times the derivative of the inside, which is just 3, because the derivative of 3x is 3, but this is a constant, and the derivative of a constant is 0. So the derivative of the inside is just 3, and I'm going to write that as 3 times cosine of 3x minus 1/4 pi. Okay? All right. Take another minute, pause the video, try this one, and then check your answer with me. Okay, for this one, you do have to make sure you know the derivative of the outside. So 3x squared is inside, but the derivative of the outside, you have to know the derivative of cosecant. And that's going to be negative cosecant cotangent. And remember, the inside stays the same. So for both of those, the inside stays the same. And then we will multiply by the derivative of the inside, which is going to be 6x. And so I have this negative, I have the 6x, I want to write that in front. So that's going to be negative 6x, and then I'm going to have cosecant of 3x squared cotangent of 3x squared. Okay? So that's how we take the derivatives of fairly basic trig functions. But let's look at this one, because this one can be tricky because of this 2 right there. Okay? That says sine squared. So I highly encourage you to rewrite this function where you see the squared outside. So we're going to write it as sine of 3x cubed minus 5x all squared. Because what happens now, hopefully you can see, is you have chain rule as my outside function. And then this is my inside. And so you have to be very careful. I probably want to go over here and ask myself, what is the derivative of just the inside? Okay, the part without chain rule, so that when we put it all together, it's a little bit easier. So if I want to take the derivative of this, remember, I'm taking the derivative of the outside, which is going to be cosine. Inside stays the same, times the derivative of the inside, which is going to be 3 times 3 is 9x squared minus 5. So this is what my derivative is going to look like when I take the derivative of the inside. And if you want to, you can write that 9x squared minus 5 first, and then the cosine of 3x cubed. So it's very beneficial sometimes to break this down and find this derivative first. Because now, watch what happens. When I take the derivative, I'm going to have chain rule. So the 2 comes in front. Inside stays exactly the same. This is chain rule. Subtract a power, which is going to give me 1. And then times the derivative of the inside, which now we've already found, so we won't accidentally leave anything out. So I can just tack that on as the derivative of the inside. And so that can get really troublesome and people accidentally leave things out. So it might be beneficial to do this. Now, if I'm rewriting this, I'm really just going to put things in a different order out of my own personal preference. I'm going to leave the 2. I'm going to take this factor right here and I'm going to write 9x squared minus 5. And then I'm going to put this and this in either order really. So sine of 3x cubed minus 5x. And then cosine of 3x cubed minus 5x. And that's my derivative, guys, and there's a lot to that, and it's very easy to miss something. So break it down and do it piece by piece. Also notice that 3x cubed minus 5 was what started with the inside of my trig, and it's on the inside of every single trig. It doesn't change. Okay, so don't accidentally change that. I see that a lot. Okay, be very careful. All right, so I want you to rewrite this one. We're going to rewrite this as f of x equals cosine of x to the 4th. Now I want you to pause the video for just a second and try this one, and then check your answer with me. Okay, so again, f prime of x, if you want to, and this one's a little bit simpler, but you can say, I know that cosine is on the inside, so what's the derivative of that? The derivative of cosine x is negative sine x. So now I already have the derivative of the inside. You can label it inside or do it however you need to not get the wrong answer. So now when I do this, my outside function is chain rule. I'm going to say 4, inside stays the same, that's cosine x, subtract a power, which this time gives me cubed, times the derivative of the inside, which is nice, we already found it. So times negative sine of x, and then I'm just going to kind of rewrite this a little bit. This is like having a negative 1 times 4, which is negative 4. I'm going to write my sine x first, and then when I write my cosine, instead of writing it as cosine x all cubed, we're going to go back to our normal notation, cosine cubed x. And that's my derivative, okay? Okay, let's look at this example. Now we're going to be combining rules. So you see that we have a natural log right here and a sine cubed on the inside. So we know that the rule for natural log is the derivative of the inside, which would be this, over the inside as you see it. So that's not too bad, but you may still want to come out here and you may want to take the derivative of this sine cubed x just to make sure you have the derivative correct. And now the derivative of that is going to be, so this is chain rule. If you need to see this, you could write it as sine x cubed. So this is going to be bring the 3 to the front, inside stays the same, subtract 1 from the power, and then times the derivative of the inside. And the derivative of the inside in this case is just cosine x. And so we would probably write this as 3 sine squared x cosine x. That's just the derivative of the inside. So now when we go over here and we say, what is f prime of x? Remember that the natural log is going to go away, and we're going to take the derivative of the inside, which we've already found, 3 sine squared x over cosine x, and then it's always over the inside exactly like it was initially. So we have sine cubed x in this case. Now, we can simplify this because I have a sine squared on top and a sine cubed on the bottom, and so what I'm going to be left with is a 3 cosine x on the top and just a sine x on the bottom. And we can even go a little bit further because cosine over sine is cotangent. So we could write 3 cotangent x, and that would be my derivative. This is my derivative also. This is just a simpler form. This over here, you don't have to do this, but if you find that you're missing steps and you're missing parts of your derivative and not getting correct answers, then this is a good idea. Okay, so I want you to take a minute and I want you to try to find the derivative of this problem. Okay, so again, I'm just going to do this to show you that if I take the derivative of the inside, and I'm actually going to write it as cosine 2x all squared. When I take the derivative of the inside here, it's going to be chain rule. So the 2 is going to come in front. The inside is going to stay the same. Subtract 1 from the power, which is 1. But then we multiply by the derivative of the inside. And the derivative of cosine 2x is negative sine 2x times 2. So we still have to multiply by that. So that's like a double chain rule. Okay, it's the chain rule with the trig chain rule. So you've got to be very careful. Now, this is a negative 1, and this is a 2 and a 2, and those can all be multiplied together to get negative 4. And then I have cosine 2x sine 2x. So that's my derivative. I want you to notice that whatever started inside my trig right here, this 2x is always going to be inside. It doesn't change when I take the derivative. But a lot of people forget that 2 out there. So you've got to be really careful. So that's the derivative of the inside. So when we take our derivative here of this natural log of cosine squared 2x, we're going to have the derivative of the inside, which we already found, negative 4 cosine 2x sine 2x over what was already there, so cosine squared 2x. Okay, again, the natural log goes away. So if I simplify this a little bit, I'm going to still have my negative 4 on the top, but there's 1 cosine 2x on the top and 2 cosine 2x's on the bottom. So one of those on the top is going to cancel, and I'm going to have 1 left on the bottom. And then I do still have my sine 2x. And of course, sine 2x over cosine 2x is tangent 2x, so I'm going to have negative 4 times tangent of 2x. And that's my derivative. Okay, now we're going to put it with rules for E. Okay, so all of our rules just kind of get put together. I want you to take a minute, and I want you to try this one and then check your answer with me. Okay, so we have y, so we're going to say dy dx equals. Remember that with E, everything stays the same. So initially we're going to write everything just the way you see it. But then we have to remember that we have to multiply by the derivative of the power. And so the derivative of sine 2x is going to be cosine 2x, and you have to remember to multiply the 2 because that's what's inside cosine. So we have to multiply by the derivative of the inside every single time. Not really a real pretty way to write this. I like to write the 2 first. And then it's kind of preference. I'm going to write cosine 2x. I'm going to put that in parentheses if I'm going to put this e next to it so that it doesn't look like my e sine 2x is inside cosine. So however you want to write that is fine, but this is my derivative. Okay, again, pause the video and try it. Okay, so the same concept on this one, it's e. If you need to, again, you can take the power, because we know we're going to have to take the derivative of the power. And you can take that out to the side and you can write cosine of x squared. Remember, when we see cosine squared of x, this is how we need to think about it because it's chain rule with trig rule. Okay, so if you need to take this out to the side and do it, then please do that. I don't want you to get it wrong because you're trying to do it without writing what you need to write. So if I take the derivative of just the power, I'm going to bring the 2 in front. The inside is going to stay the same, and then I'm going to subtract a power, which gives me just the 1. But then I have to multiply by the derivative of the inside, and the derivative of cosine is negative sine x. So this will simplify to negative 2 cosine x sine x, and it doesn't matter what order you put those two in. So when I take the derivative here, everything is going to stay the same. That's the rule for e. So everything stays exactly the way it was, and then we multiply by the derivative of the power, which we found to be this over here. So I'm going to have negative 2 cosine x sine x. Now, I can multiply this negative 2 by this 3 and just leave it the way it is. You guys do have your trig identities, and this 2 cosine x sine x, which would on your reference sheet be 2 sine x cosine x, could be simplified. We don't necessarily need to, so I'm just going to leave it like this, but I'm going to write negative 6. And then, again, it doesn't matter what order. So if you want to write the e first, I'm just going to put times cosine x sine x. Just be careful to make sure it doesn't ever look like your e is part of the inside of your trig, okay? Okay, now, this is product rule with e and cosine. Do you see here that it's e to the negative x times cosine x? So now you've already learned product rule, so I want you to take another minute, pause the video, and try this problem. Okay, so dy dx equals first times the derivative of the second. The derivative of cosine is negative sine x, plus the second times the derivative of the first. And remember, the derivative of e to the negative x is e to the negative x times the derivative of the power, which is negative 1 in this case. That's it. That's my product rule. We just need to clean it up a little bit. So I'm going to write, this is like a negative 1, and I'm going to put the negative in front. And then it's kind of up to you. You can write the e to the negative x. You could actually write this as 1 over e to the x. It doesn't matter. Sine x. And then I'm going to bring this negative 1 in front. So that's going to make this minus e to the negative x cosine x. And in this case, remember, we always want to look for a greatest common factor if we have one, because a lot of times that makes it really a lot simpler to solve. So I see that I have an e to the negative x. You could even take out a negative e to the negative x. And when I do that, I have sine x plus cosine x left. And this would be a lot simpler to solve or find stationary points than this would be. Okay? So always look for those when you can, when you have one. Okay, this is the last problem, and there's a little bit going on here, so I want you to try this and be very careful that you don't forget any little pieces, okay? Okay, all right, so this is product rule. This is x cubed times, and then this is sine squared 5x. Now, that's a lot, so if you need to, again, we're going to do it this way because this is going to be actually sine of 5x squared. So if you want to go ahead and take the derivative of that first and then just pop it in when you need that derivative, it's going to be 2, inside stays the same, subtract a power, which is just going to give me 1, times the derivative of the inside. And the derivative of the inside, remember, is cosine 5x times 5. We've got to always multiply by the derivative of what's inside of the trig. Simplifying this is going to give me 2 times 5 is 10. And then I'm going to have sine of 5x times cosine of 5x. Okay, so that's my derivative. So now when I do this product rule, I'm going to say dy dx equals first times the derivative of the second. So that's where we need this. So now I can just pop it in there. Okay, so this was first times the derivative of the second, plus the second, which is exactly like you see it, times the derivative of the first, which is this x cubed, and that's going to be 3x squared for that derivative. And that's kind of pretty much it. I could write this 10 in front, so 10x cubed, sine of 5x, cosine of 5x. And then I personally like to write the 3x squared first. So I have 3x squared sine squared 5x. Now, again, in this case, you could take out a greatest common factor. Let's see what that would look like. I have an x cubed and an x squared here, so I can take out x squared. And I have a sine 5x and a sine squared 5x, so I can take out a single sine of 5x. And then what I would have left is I would have this 10x left, and I would have a cosine of 5x. And then over here, I would have a 3, and I would just have a sine of 5x. And that's really as far as I could go. So that's my derivative, okay? And that would be easier to solve than this one, okay? Because this is really like factored form. This is a factor, this is a factor, and then this whole parentheses here is a factor, which we could solve if we needed to, okay? Hope that helps. If you need to go back and review anything, do that, and I will see you in class.